This talk is about my very first project in my very first SRE job, which I started last year. And lucky me, DNS is my topic. This is about how we regain control over a very chaotic DNS setup. I work for a company that's called eGym, and our mission at eGym is to make the gym work for everyone. We are in the fitness market, a very tough market to digitize, unless you're Fitbit maybe. We want to digitize the whole training floor, and we do this by building and designing our own digital strength machines. They are distributed all over the world in gyms. Tens of thousands of machines, so we run an IoT network, if you will. All these machines, they send their data to a central point, which would be called the fitness cloud, and there we unify training data across vendors. So not only our machines, but also machines from partners send their data to our fitness cloud. And on that data, we run all kinds of data analysis, and the results are presented in apps for users, for trainers, and for the gym owners who ultimately buy our machines. We also do research projects where we improve customers' health by introducing new training methods specific for some diseases. A year ago, when I joined the company, coming from a world where everything is hierarchical and in order, I found this. We're a small company. We don't host any customer domains, yet we had 200 domains spread over 5 registrars, served from over 30 different name servers, and not for redundancy. It was spread because we could. We had interesting naming schemes, so an artifact named foo run by a team named tu would get the name foo.tu.ts, that is for teamspace, .egym.com. And all that because we wanted to find a spot in the market and make a profit. So we would do things first and ask later, and that results in chaos. How much chaos? At the right side, I tried to reproduce one of our setups. And you can see that if you want to resolve the name down there on the bottom, x.cu.ts, whatever, you have to jump through a couple of name servers because our organizational structure, our teams and how they were structured, we put that directly into DNS and used NS delegations to make that more fun. Horrible lookups, hard to debug, slow for our customers, especially for services that we run with very low TTL of a couple of seconds. Then you always have to jump those hoops again, and cache is invalidated. Funnily, we managed to run into the limit on Google Cloud DNS for maximum managed zones, because every subzone would be its own managed zone on Cloud DNS, and every managed zone on Cloud DNS gets its own set of DNS name servers. And at some point, we ran into that limit. I jokingly say sometimes we made Google run out of name servers, but that is maybe a little bit exaggerated. Our deployment strategy in general was more YOLO, go to the Google Cloud DNS web interface, put something in there, and see what happens. That DNS thing was kind of a haunted graveyard, and only a few SREs were even dared to touch DNS, and developers were not really empowered to touch DNS and make changes, although they did sometimes. Lessons we learned from just looking at what we had is that you should never force your organizational structure onto a technical infrastructure in DNS. So don't do NS delegations if you have a couple of teams. Find other ways to empower people to do DNS changes without affecting other zones. And it is also helpful to have company-wide unique artifact names. So an artifact named foo run by team A should come from the same code base as the artifact foo run by team B. Otherwise, it can create a lot of confusions, and names don't really resolve to the code anymore. OK, so looking at this and coming from a world where everything is not fast, but well in order, I wanted to improve the situation and try to understand what is a problem actually. And I think there was a conflict. At least this is how I started this. And from SRE perspective, it was one does not simply change DNS. This is all production. The pager goes off. don't change don't change DNS. And the devs were agility. I have deadlines. I have a product owner. I need to develop. I need to change something. I need to divert traffic from service A to service B. SRE is in my way. Then SRE said, how do you roll back your changes? All your agility is nice and fine, but how do you roll back? You have no strategy. You have no version control. We build it, we run it. If we break it, we fix it. OK? Arguments got more technical. The web interface does not provide atomicity. So you have change sets that change something in DNS, and then you need another change. And after that, it is in the desired state. And in the meantime, customers could be affected. And then I think we found the root cause of all this. SRE is too slow changing DNS. And right they were. It took us hours to days to review DNS changes and then apply them manually to production. So developers did not want to wait that long and just change it themselves. What do you do when you can't win a war? You look what all strategists did, divide and conquer. I think it was Caesar, but I don't know exactly. So we looked at all our DNS data and found out there is some data that is very volatile, and that is what was changing all the time. And then we have some data that is kind of stable and not really changing all the time. And I chose the name volatile in production here for the categories, but it could be any other name. And what I wanted to achieve by dividing those DNS data is to give developers a space where they can have all the agility that they need, and that helps us conquer the market, and that helps pay my bill and pay my salary, and helps the company to thrive. But also something where I can rely on that it doesn't go off in the middle of the night because someone thought about changing something in DNS. So in the volatile DNS space, we allow everything that you can do and everything every developer can do, whatever he or she wants. And in the production space, in the more reliable space, we want to have tested changes and some version control and the rollback strategy if things go wrong. So the question, or the answer to the question, do we really have competing goals is, no, we don't. SREs want reviewed version control changes in production, and devs need rapid change during development. And there is some overlap between those goals, but that overlap is really minimal. So now that we found out what we want to achieve and how we want to divide the space in DNS, it was about, we had to think about how do we want to store this data. And every engineer at eGym is proficient with Kubernetes. That's a skill that everyone has. And everyone uses Kubernetes every day. So that means YAML is the lingua franca at eGym for all kinds of configuration changes. So we quickly settled on we want to define our DNS data no longer in zone files, but we want to define it in YAML files. And the YAML files could be stored in the Git repositories, and every developer could have access to that YAML files and make changes, which is what was a very different process from before, where only SRE was allowed or even able to access the data and make changes. We built in templating functionality, and I want to say some words about templating. I have a mixed view on templating in general. For me, templating always is a trade-off of two very important principles. The first one being the principle of least surprise, because whenever you pull in some data or definition data from a template, it is kind of hidden away. If I go one slide back, you can see the red arrow showing that we pull into the egym.coffee zone two templates named Gmail and website. And it's not really clear what they do until you look at those templates. The other principle that I like is don't repeat yourself. If I have 200 domains and all of these domains are handled by Google Mail, then I definitely don't want to put in my whole set of name servers in every configuration file, especially if I want to change something. So the trade-off between those two principles is where the templates live. And we decided to go with small templates for logically bounded things like a set of mail server, a set of name servers, or putting a domain into parking mode or something like that. We made sure that our software cannot pull in a template from within a template. So there's only one level of templating, and that is by choice. It may not make much sense in larger setups, but for that small setup that we have, it works quite well. OK, now we have all our resource record data and all our DNS data defined. How should we validate it? For that, we wrote a little Go package. It is called the Resource Record Database, or RRDB for short, with very limited dependency, very small binary. It has high test coverage, because DNS is highly critical. Unfortunately, it is now beta tested. I'll go into that later. But let me first talk a bit about the internals of RRDB. RRDB leverages the fact that our DNS data nicely fits into memory. As I said, we only have 200 domains, a couple of thousand records. That's not much. That fits nicely into every machine's memory. And it uses a Trie data structure. Trie is one of my favorite data structure. I think it's a beautiful thing. And in a Trie, you have a root node, and that root node can have pointers to other nodes, and those pointers are named. And DNS is basically the same. You have the root label. It's not called node, but it's called label in DNS. But other than that, it's basically the same. It's a hierarchical system. So we have the root node. We have a .com, the TLD pointing to the com node, and then to the egem node, and then to the my service node, and so on. And at each point in this data structure, we can attach these red fields, which are resource records, to a node. And this we can rebuild the whole final data set of all our domains in memory. And now we can run a couple of tests in memory before even deploying. What we do is we do some logic checks within the nodes. So if a node, for example, has a CNAME record attached, then it must not have an A record. That is a limitation of how DNS works. And we can validate this in memory even before a change goes to production. At some point, we learned that it is nice to have back and forth pointers. So every node now also points to the parent node. And this allows us to have logic checks across nodes. So if a node has an NS record, which is a delegation of a subzone to another name server, then that node should not have any children, because those children will never be served from that DNS server. So the data structure that we have in memory, we can walk and query the Trie and run all kinds of checks. And I even have the idea of maybe using inheritance on propagating TTL values or something. Haven't decided about that yet. What went wrong? A couple of things. Due to time constraints, I will only go into detail of one. So we had this foobar.egem.com service serving a quad A record. At least that is what we believed to be serving. Turns out this was in the middle of the migration period. A couple of data was automatically migrated from zone files to those YAML files. And we had an NS record in there. And this was before we had the parent pointers and all the checks. So what we were actually serving for foobar was the quad A record of the old DNS server, which was still alive because we were in the middle of the migration. And then at some day, don't remember, but probably a Friday, I said, oh, cool, let's kill all the old infrastructure, end of life that server. Funny weekend. Took us a while to find that out, modified first fixed the incident, of course, and then we modified the package, the RRDB package, to detect these kind of changes. And now, then we ran those checks that we just programmed and found 2 other places where it also happened, but without customer impact, luckily. Now, with all those new tools, we were able to change our process. Our process before was someone making a ticket, please change this or that in DNS, and then at some point, SRE would pick up the ticket, depending on the load and maybe on the mood, and would review the changes, have a couple of questions, of course, and then at some point deploy the change very carefully and hope that nothing breaks. The new process is a little bit more straightforward. The repository is hosted on our company Bitbucket account. This is important because that is out of band, and DNS, we figured, should be out of band. Another disaster. Every developer can make a DNS change in the YAML file, push the commit, and then the first thing we do is we start a pipeline. We use the pipeline feature on Bitbucket and do a YAML lint just to see that everything is kind of nice and people don't start using their own style. It's not a very strict check, but at least it makes sure that things stay readable. Then the whole new proposed DNS dataset is loaded with RRDB, and all the logic checks are performed. And if these work out great and everything is fine, then the pipeline continues. And we do a full deployment run on staging. So I said we use Cloud DNS, Google Cloud DNS, and every managed zone that we have the zone in 2 projects, one in the production project and in the staging project. And we do a full deployment run on the staging project that is not active. No one queries those name servers. The domains are not delegated to those name servers. But that allows us to verify that what we just figured out we want to deploy is really deployable using the Cloud DNS API. So there's very little chance that what goes well on staging goes wrong on production. It's a super cheap additional check. It runs for about 45 seconds. The Cloud DNS bill for that is about $1 a month. It's really worth it. Only after all these checks have been done, the manual review comes in. And now the review process allows every other engineer to sign off that change. Note that a DNS change on production can be issued by one developer and signed off by another developer, and SRE has no say in that, unless we see a really big problem and want to object. But usually we don't. And developers nowadays are empowered to do a DNS changes, and they do that very carefully and very good, and it really helped shed some load off of SRE to developers. And if everything is fine, things go to production. A Slack bot will usually announce production changes on our deployment Slack channel. And that is just an additional safety measure, so people see when that change went into production, and also other people could point out, oh, wait, that is not a good idea. So there was a case where this saved us, and we could quickly roll back because we had this additional human check after deployment. A lot of developers watch the deployment Slack channel, and so this is a nice feedback loop for us. The benefits of the new process, as I said, all of the moving parts are now out of band, and that helps because sometimes the infrastructure that you need to deploy DNS is referenced in DNS, and that is not a good idea if things go really wrong. That we don't have that problem anymore. Another thing is that the pipeline run takes about 1.5 minutes compared to the hours or days changes took before we had this. That is a huge improvement, and we can, in general, deploy changes within minutes compared to days before. Lessons learned from all that, from all the automation. I think the most important lesson for us was that the automated checks give people more confidence, and we empowered people by having automated checks, including us, including SRE. There are some things we don't have to check manually anymore because we know we have an automated check for that now. I urge everyone to think about how to democratize critical infrastructure. I think it is not worth being overly protective about some critical infrastructure. In general, I'd like to eliminate the elitism that comes with a couple of things, and DNS is one of those. Go out there, find the haunted graveyards, find the things that no one likes to touch, and de-haunt the graveyards. I don't even know if that is an English word. Some reference to other battle-tested existing tools. We have Record Store from Shopify, OctoDNS from GitHub, Denominator from Netflix, and DNS control of Stack Exchange. For the first three, they did not really work for us. The fourth one, it would have worked if we knew about it. So very painful to admit this, but the lesson is we may have fallen for not invented here, and I blamelessly blame myself for not doing proper research. Some achievements we unlocked, some expected, some unexpected, by automating a lot of the DNS stuff. It is out of band, I mentioned that already. It is not scary anymore, so that shed some load of SRE. We got certificate automation in Kubernetes, and as I said, we are a heavy user of Kubernetes. And now the whole certificate process is worth another talk, maybe. It also took days and was a lot of manual work, and it was done in SRE mostly. And now, if you can create an ingress object in Kubernetes, you for free get that certificate signed by Let's Encrypt. And what we also gained is configuration-less delegation monitoring. So that means if someone tries to take over one of our many 200 domains, we immediately get a page. That does not happen too often. Our tools are open sourced. There's a very long article about all of that on our tech blog. And if you're interested in fitness challenges, of course, like everyone else, we're hiring. Thank you.